In this video, we are going to discuss about instruction and instruction sequencing. So, if we see generally the computer must perform four type of operations regarding the instructions. So, one is input-output transfer and arithmetic and logical operations on the given data, and it will perform program sequencing and control. Then it will perform the data transfer between the memory and the processor register. So first let us discuss about register transfer notation. So here the data must be transferred from the memory to the program register. Then because all the data on the instruction regarding the program are stored in the memory, so therefore it is necessary to transfer the data from the memory to the program register. Okay. So you can see there is a bidirectional transfer from the memory to program register and program registers to the memory, and the same the case for the input output. So the location of the data, that is it is named as a address of the memory. It is named as location, LOC, or variable, VAR, A, and place. Whereas a processor register, it consists of R0, R1, R2, R3, R4, and R5. The input subsystems, it has data in and data out. Suppose if we see the example, what is register transfer notation means, the R2, this open basis and closed basis represent the content present in the R2 and R3. So the content present in the R2 and R3 get added, and the result is stored in R4. So this is nothing but a register transfer notation. Next, we will go for the assembly language notation. So here I have already told you we have to transfer the data that is present in the memory to the processor register. So R2 is a processor register, therefore the load is is called as mnemonics, which is used to transfer from the data from the location from the memory to the processor system. So whatever the data that is present in this location, that is get transferred to the processor register, that is R2. Then we have to add R2 with R3, and the result gets stored in R4. Okay. So here this R4 is nothing but the content which is present in the R2 and the R3 get added, right? So this is what we have discussed here. So this is nothing but the register transfer notation, whereas in assembly language we use load and add mnemonics. Next is reduced RISC and CASC. So these are the two different approaches which is used in the design of the instruction set. So these are called as instruction sets. This is one instruction, and this is the second instruction. So these type of instructions are called as instruction sets. So in RISC, each instruction must this is about RISC, okay, reduced instruction set computer. So for reduced instruction set computer, each instruction must occupy exactly one word in the memory, okay, and all the operands need to execute a given arithmetic or logical operation specified by the instructions are already in the programming register, processor register. So it gets stored in the pipeline fashion, okay. So the restricted number of, there is a restriction regarding the number of different types of instruction that may be included in the instruction set of the computer. So such computer is called as reduced instruction set computer, okay, which is very simple compared to the CASC, and it is easy to understand. So the next topic is introduction to RISC. instruction sets. It has two key features. One is each instruction will fit into a single word. Next, it will uses a load store architecture. That is, the memory operands are accessed only using store and load instructions, and then all the operands involved in the arithmetic and logical unit must either be in the processor register, or one of the operand may be given explicitly within the instruction word. So whatever the operation we are going to perform, that is should be with the help of the processor, that is R0 to R5, or the operand must be explicitly present within the instruction words. Okay. So here you can see I am going to perform addition. The content present in the A and B get added, and the result is stored in the C. So here you can see I need to move the content from this is nothing but variable, right? Variable which is a memory resist, which is in the memory, right? So I'm going to move the content which is present in the A to R2 with the help of the load command. Similar way, I am going to move the content from the B to processor register R3 using the command load. So these two get added and the result is stored in R4, right? So here the R4 value again it will store in the memory register C. Okay. So here you can see how the so suppose this is my address, I is my address. So in the memory it will store load R2 comma A after the after I plus 4 address, right? So the I plus 4 address the load R3 comma B gets stored. It is that, right? Then I plus 8 add R4, R2 and R3. So it is like, okay. So it will be stored like this. Okay. In the memory. So this is the content which is in the present in the memory, and this is the address of the location, right? So what is a program counter? So the program counter, the processor which contain on register, that is called as a program counter. So it will hold the address of the next instruction to be executed. Suppose currently if the load R2 comma A is executing, if you check the value of the program counter, it will store the address of the next instruction to be fetched. So the program counter currently it is having I plus 4. So after this occasion, it will execute the next program. Okay. So this is the role of the program counter. So you can see in the processor you have a control circuit. This is the control circuit in the processor which uses the information in the program counter in order to fetch and execute the instructions one at a time in order of increasing order. So this is called as straight line sequencing. So the control circuit in the processor which will uses the information in the program counter in order to fetch and execute the instruction one at a time in the order of increasing address, which is called as straight line sequencing. So basically how the instruction is executed means first we have to fetch the instruction. So we know that the instruction is present in the memory. So the instruction is first from the memory location and whose address is located in the located in the program counter, right? Once the instruction get fetched, next it will go for the instruction register in the processor. This is called as IR. The fetched instruction is stored in the instruction register. So this is called as first phase. Next second phase is instruction executing. So whatever the instruction that is there, it will get executed. So the next topic is branching.